Okay, we'll begin and today's lecture we'll take a look at object-oriented programming, and there's several object-oriented programming systems in R. We're going to look at the first one, S3, and then we'll talk about that. All right, okay, so if you've seen another programming language, you might be familiar with concepts of OOP. If you've never seen OOP or object-oriented programming before, that's also okay. But we do have four, I think now five R systems of OOP in R. We've got S3, we've got S4, we've got RC reference class, R6, and then now there's S7. Which is it's kind of a unique thing to R. I don't think other programming languages have as many OOP systems, but that's okay. We're gonna focus mostly on S3. Well, today's lecture will focus only on S3, and then I'll have another lecture on R6. Okay, but that will be that. Okay, we'll skip the other ones. All right. The S3 system, as well as S4 and I guess S7, use generic function OOP, and that is in contrast to encapsulated OOP, which is RC and R6. In generic function OOP, the methods belong to functions, and in encapsulated OOP, the methods belong to the classes, belong to the objects themselves. So if you come from, say, Python or Java or C++, those languages use an encapsulated OOP, okay? And you might be more accustomed to that, okay? Generic function OOP is perfectly valid, but it is different, and it might feel a little bit awkward and a little bit strange. It's a little bit like learning a foreign language. So in English, our sentence structures are often subject, verb, object. And if you go to another language with a similar sentence structure, like Spanish, where you have also sentence, verb, object, it's not too hard to switch. But then if you take an entirely different language, okay, other languages might have, a completely different sentence structure. And so it might be a little bit difficult at first for your brain to wrap around. But it's not like that language is any worse or less valid of a language. It just has a different kind of structure. And similarly, generic function is a different OOP paradigm than encapsulated. Not wrong, just different, okay? The way encapsulated OOP works is the functions, which we can think of as verbs, the functions and methods, they belong to the objects. So yeah, Python, C++, Java use encapsulated OOP. Their format is usually something along the lines of the object $ method name. So in Python, it's like list.append or list.insert or something like that. But in R, it's a little bit different, okay? Well, we have R6 and you have something like that object $ method. And you can think of it as you have an object like the camera object, okay? And the methods that belong to the camera object are basically the things you can do with a camera. So you can say, all right, we have method shoot that allows you to take a picture. Okay, we have method focus. You can have the camera focus on something. You have method, record video, things like that. Okay, the camera itself will store information like the pictures, how many pictures it's taken and stuff like that. And we have that. That's encapsulated. Okay, generic function OOP, on the other hand, uses generic functions, and the methods belong to the functions. All right, and so when you have generic function OOP, you have something called polymorphism. Polymorphism means this function behaves differently depending on the object that was given to it. okay? And I would say this is actually a little bit closer to how we use verbs in English, okay? Verbs in English, depending on the object we give you, take on different meanings, okay? So if I say we have the verb shoot, okay, depending on the object I hand to you, you are going to take a different action, right? So if I hand you a camera and I say shoot, you will hold the camera up to your face, look at something, and take a picture, okay? If I give you a hockey puck and I say shoot it, you will like look for a stick and you'll try to hit the hockey puck with the stick, right? If I give you a gun and I say shoot it, you'll point the gun at a target, okay? And so the verb there takes on different meanings, and you would understand that you need to take a different action depending on the object that I give you, okay? And that's how polymorphism works in an object-oriented system, is that you have a generic function, and depending on the object you give the generic function, exactly what it does is a little bit different, okay? And so here's an example of a generic function, a polymorphic function that behaves differently depending on what you give it. So we have the function summary, okay? And summary at a high level is supposed to give us summary information about a vector of values. But depending on the kinds of values I give it, it's going to give us different results. So in the diamonds data set, there's different columns. One column is the caret, the size of the diamond, and it's a numeric variable. So if you give a numeric variable to the summary function, it gives you basically a 5-number summary plus the mean. It gives you some summary statistics. It tells you the minimum caret size, the max, the mean caret size, things like that. There's another column in the diamonds data set, the cut column. The cut column is a factor, okay? It's an ordered factor, and it says, you know, this diamond has a good cut, or an ideal cut, a premium cut, things like that. And when you call summary on that, the output here is basically the count of each of these categories. It says there were 1,610 fair cut diamonds, 21,551 ideal cut diamonds, so on and so forth, all right? So internally, the calculations that R is doing is very different, right? Here it's, you know, adding them up and figuring out quantiles and quartiles. Here it's, you know, doing counting operations. But we don't have to think about what internally R is doing. We can just say, hey, I just want some summary information, right? If you give the entire data frame to summary, you're going to get like summary stats for each of the different numeric columns in there, right? So summary will behave differently, run different code depending on the object you give it, all right? And that's polymorphism. And basically it is, it simplifies your life as the coder, all right? So, and it simplifies our speech, right? Like we can tell somebody, you know, I want you to, I don't know, I want you to take care of this, right? And that's a very generic instruction, and you're counting on the person to be able to take the object that they've received and figure out what to do with it based on that, right? You know, probably you want to be a little bit more specific, but here we can just say, hey, I want a summary, and we don't have to be like, oh, I want a summary, and remember it's numeric, so calculate them this way. Oh, and I want a summary, but remember it's a factor, so calculate them this way. You just say, hey, I want a summary. R figures it out. Okay. Yeah, question.
Yes, if it's a factor, and it's sort of like is it the same as using
for this, yes, yeah. For that, it would be. But yeah, I mean, again, that's a little bit extra mental workload to be like, oh, I have to remember this was a factor, so I should be calling table or something versus, hey, I just want a summary of this variable, and so this reduces kind of the mental workload on your part. You don't have to remember all of these different things. Okay. All right. So the way all object-oriented systems work, whether it's encapsulated or generic function, is we have these concepts of classes and methods. Classes are basically the types of the object, and methods are the functions and the verbs. Okay, I've got a little bit too much stuff on all of this stuff. Okay, there's another important concept, and that's inheritance. Inheritance allows us to define new classes or subclasses that inherit from parent classes or superclasses. So we have child classes and subclasses that inherit from parent or superclasses. And this allows us to create new classes without redefining everything. Okay? We can say, hey, I want an ordered factor, and really it's going to have almost all of the same properties as factor, except it's got this ordered characteristic, right? A tibble inherits from a data frame. It behaves a lot like a data frame in many ways, but it does a few things a little bit differently. Okay, you can think about like in biology and taxonomy, we can define species that inherit from genus, and I don't know what is it, kingdom, phylum, class, order, stuff like that. And so cats, house cats, are basically a subclass, a species that belong to the genus feline. And feline also includes other species like leopards and cheetahs and lions and stuff. and so there's certain similarities, but they're also a little bit distinct. Yeah, question. Yes, so child classes will, when you have methods defined in the child class, that will basically supersede the generic, not the generic, but the methods from the parent class. Yeah. All right, when we have generic function OOP, which is the system we're going to be looking at today in S3, we have something called method dispatch. Okay, method dispatch is the process that R goes through when you say, I want the summary, and R says, oh, okay, you want a summary, but you gave me a numeric variable. So what I need to do is I need to find, I need to perform this action, and it has to find the code that says, figure out the mean and the median and the stuff for a numeric variable. Okay. Method dispatch also says, okay, you called summary, you gave me a factor. So now I need to find the code, the function, the method that's going to tabulate the count of each of these categorical variables. Okay. So when you call the generic function summary, R checks what kind of object was given to it, and then it finds the appropriate method. Okay, and so we'll take a look at that. All right, just a quick overview of the different OOP systems we have in our S3. This is the one we're going to be looking at today. It's generic function, but it's very informal. Okay, it's very informal. It relies on naming conventions. Okay, it's entirely powered by naming conventions. So if you name things incorrectly, S3 is going to break. But it works, and pretty much everything in base R, everything in the stats package runs off of S3. And so you can do quite a bit with S3. But there's no guardrails, right? And you're going to see, like, we can just break some things. And so S4 is a little bit more of a formal system, and it puts on some checks to make sure you're not doing anything that you're not supposed to be doing. Okay, and that's implemented. And then later on, people said, hey, you know what? I want the encapsulated version. I like this stuff that we do in Python. I like this stuff we do in C++. I kind of want that in R. And so they created RC reference classes, and that was fine. And then people said, oh, you know what? There's a few things that reference classes do that is annoying to me, and I don't like it. So I want, so they created R6 as a way to kind of avoid some of the annoyances here. and then later on said, oh, I didn't know you could just get rid of annoying things by creating a new OOP system, because there's annoying things that S4 does. And but I also want the generic things, and I want the formal rigorous checks and stuff, but I don't like the annoying things S4 does. So I'm going to create a new one, and we're going to call that S7. So that's just what it goes. And who knows? There might be like, oh, R6 does more annoying. I don't know. And we're going to end up with, you know, something in the future. I don't know. But anyway, we're going to talk about S3, our basic OOP system. And we're going to start with base types. Base types are actually not part of any OOP system. That's everything that's just in the base R. Your atomic vectors, your lists, your functions, those are all base types. And basically everything in our OOP systems are built out of base types, right? So these are the fundamental building blocks. We take them, we put them together, and we get something more complicated, okay? All right, before I go on, let me give you your first view quiz answer today, which is the letter D. D as in dog. D as in dog. Okay, so yes, everything in our object-oriented systems are built out of base types. Okay, so as far as base types go, we don't have to worry about a lot of this stuff. We generally just think of like what is the information that's stored in there, and that's the object's contents. But technically, all of the base types in R is actually a C structure. It contains additional information, stuff that handles memory management, and information about what the type is. Okay, we never have to worry about memory management in R, which is a nice thing. Okay, if you've ever taken a class in C++, there's like a whole bunch of stuff that you have to do with memory management, where you have to kind of basically clear out your variables and stuff after you're done using them. Otherwise, it just keeps adding up, and you can have memory leaks and all kinds of problems. R handles all of this for you, right? The exchange is, R is going to be a little bit slower than like C++. C++, you get like really fast performance. And R says, you know what? I will handle a lot of this stuff for you, but because I'm handling a lot of this stuff for you, like I'm going to be a little bit slower. And we accept that trade-off, okay? Because we don't want to have to worry about memory management, okay? But yeah, everything's built on these base types. And so, but one of the annoying things, is that the base types are a little bit like named funny, and there's inconsistency. And so you have functions, and you can say, is the mean a function? And that's true. But if you say type of, instead of saying it's a function, it's a closure, okay? And there's actually two types of functions, base type functions in R. There's functions that are written in R, and then there are special functions that are called primitives or built-ins that are actually implemented in C or Fortran for speed and computational efficiency. And so whenever you make a call to it, R actually doesn't run it in R, it runs it in C or Fortran. So when you call sum on a vector, like a numeric vector, R doesn't do the summation in R. It runs some C code or Fortran code, I'm not sure, but it's called a primitive function. Or if you call type of, it's a built-in, and it actually executes the summation in a different thing, and it gets that value back. And that's just so that adding numbers can be done quickly in R, okay? But then when you ask for like, hey, what's the mean? That's basically going to make a call to sum at some point and then divide by how many numbers you have. And that's just implemented in R, okay? So when you write your own new functions and stuff in R, like you're writing functions in R, these are functions and closures, okay? All right, we have a function called isObject, and this just checks to see if something is an object, and that will return true if it's an S3 object, an S4 object, or an RC, a reference class object, or things like that. Base types will be false. So if you say, if it's like a list, a base type will be, it'll say it's not an object. All right, but let's go ahead and talk about the S3 system. Okay, S3, everything in S3 that's an object will come back as is object. We don't have a function that checks to see if something is an S3 object. There is a function to see if something's an S4 object. And so is S4 will return false if it's an S3 object, but is object will return true. Okay, it's a little bit weird and wonky. Okay, but just here's an example. So a data frame is an S3 object. So here I'm going to create a data frame, df. If I say, is that an object? That comes back true. Okay, is the data frame an S4 object? That comes back false. Data frame is an S3 object. Okay, the columns in the data frame, I've got x. X is just a vector of the integers 1 through 10. So is that an object? That's going to come back false. Okay. When you create a data frame and you use strings as factors true, it's going to take your characters, A, B, C, D, E, F, G, whatever, and turn it into a factor. A factor is an object. So I can say is object df $y. That's going to be true because it's a factor. Okay. When you type the name of a function without parentheses, right? What it will do is it returns back the internal code for that function. So, if you create a function like is prime or something, and you just type that in without giving it an argument, like check to see if this number 7 is prime, it's going to return back the code that it runs. Okay, and so here I run the code mean. Okay, all right, not run the code. I type out the name mean, and I get the definition of the function mean. And the definition of the function mean looks really weird. It's just this one line. Use method mean. Okay? Use method means it is a generic function. Okay, so remember our S3 system uses generic functions or generics, and mean is a generic function which says mean is going to behave differently depending on the object I give it, right? So it's like that verb shoot. It behaves differently. What you do with that command shoot is going to be different depending on the object we give you, okay? The command mean, that function mean, behaves differently depending on the object. And R knows this because it says use method. And use method mean says, oh, mean is not just a regular old function. We're going to have different versions of mean. We're going to have a version of mean for this type of object. We're going to have a version of mean for this type of object. We're going to have a version of mean for this type of object. And that's what use method tells us, okay? And the picking of which version to use, that's called method dispatch, okay? There are also generic functions that are implemented in C for speed and stuff. And so sum is technically a generic function that's implemented differently, but it's implemented in C for speed, okay? This square bracket, the subsetting operator, is also implemented in C. These are known as internal generics. You don't have to worry too much about them, okay? The way everything in S3 operates regarding the generic functions is based on the naming convention, okay? So if things aren't named correctly, like you have a typo in the name, it breaks, okay? So we require things to be named properly for this system to work. So when we say the mean function is generic, there's a different function of mean for different types of objects. And so there is the date class object, and you can ask, what is the mean date? And you can say, hey, I'm going to give you January 1st, 2026 and January 31st, 2026. And what's the mean? The mean is the date in between, what, January 16th or something like that, okay? But if you give it a numeric vector, 1 and 3, and say, what's the mean? It'll say, oh, that's 2, okay? And so the way it knows this is there's a function called mean.date. There's a function called mean.default, a mean.this and that, okay? We have print's a generic, and we have different versions of print. We got print.factor, we got print.dataframe, we got print. Something else, okay? time series, right? So it uses this. So the naming convention is always generic name of the generic function dot name of the class. Okay, generic name dot class name. Okay, now unfortunately, this naming convention does create a few ambiguous scenarios. Okay, so there's a function in R called t-test, t.test. Okay, this if we follow the naming convention, we would think this is the function t applied to an object of test class. Okay, that's how this would be. That's what the naming convention suggests. However, t.test actually runs a Welch two-sample t-test where you're comparing the means of two vectors, right? Okay. We have an object class called dataFrame, data.frame. And so the method for printing a data frame is print.data.frame, okay? And this is the print method for data.frame objects, which is fine. However, with this naming convention and seeing two dots, it could be confusing if there was actually a print.data function and a frame class object, okay? Now, that's not what's going on, but it is a little bit confusing. So to avoid the confusion, most modern style guides will say use the underscore, which the Tidyverse uses. So you have read underscore CSV, this underscore that, and things like that. Okay. All right. Just another example here. So most of these generic functions, you've been using generic functions and you never even thought about it being generic functions, but internally they are generic functions. So here I create a matrix X and I say I want to transpose it. That's the function T. T takes the matrix, takes something and it transposes it. And so if you look at the matrix X, it's defined to have 4 rows, okay? But then the result of transpose X is we have 3 rows and 4 columns, right? So we've transposed it, so now we have 4 columns, okay? And we get what we expected, the transpose of the matrix X, okay? Now, you probably never actually thought about this, but you can transpose a data frame, and that is actually an entirely different method, okay? Because this is, so here I have a data frame. The data frame has 4 rows. It's got 3 columns and 4 rows each. And I can say, hey, transpose the data frame, and the data frame gets transposed, and so now it has 3 rows and 4 columns. It does exactly what we expected it to do, and we didn't need to waste any mental energy saying oh, this is a matrix, so I need to call this function, and this is a data frame, so it's actually a different code, right? In both of these cases, I just say, hey, I want to transpose. I got a rectangle and I want to transpose it. I've got a rectangle matrix, I want to transpose it. I got a rectangle data frame, I want to transpose it. All right, and that keeps our mental energy easy. But internally, what's going on is that we have 2 different functions. Okay, there's t.default, which gets implemented for matrices, and then there's t.data.frame, which gets implemented for data frames. Okay, and the code is a little bit different. You didn't have to think about it. R uses method dispatch, and it says, oh, you gave me a matrix. For that, I'm calling t.default. Oh, over here, you gave me a data frame. For that, I'm calling t.dataFrame, okay? In both cases, we just called t. R does the thinking for us, okay? You can see all of the different methods associated with the generic. So here I said mean is a generic function, and so we can get means of dates. The default is for numeric things, mean.default. There's a bunch of other stuff. I don't have any idea what this is. I don't know what a mean.vector is or a mean.posit, mean.closure. I'm not sure what these things are, but these are different methods that exist. T.test, which does our 2-sample t-test, there's our default, which usually is expecting 2 vectors, a vector of x, x1, and a vector, x or a vector y, and it's going to compare the means of those vectors. But you can also give it a formula class object, like y tilde x, and it will figure that out as well. Yeah.
So if you want to do that of one of these generic methods for a specific class, would you put mean this
Yes. Yeah.
factor.
Yeah. You. This is the full name of the function. Yeah. And then and you would get the help specific for this thing. Yeah. Okay. You can also see what are all of the methods available for a particular class. So class TS is a time series class, and we have different methods. You can actually transpose a time series as well. You can plot or print. Okay. You can, I don't know, do other stuff. Okay. This is for subsetting. That's the subsetting operator, and this is the subsetting in conjunction with assignment operator. Okay, it looks a little bit funny, but if you wanted to just say like, hey, I want to change the third value, right? This is like selecting the third value, and this is like changing the third value. Okay. All right, let's go ahead and get into defining some of our classes and stuff, or creating new classes in S3. Let me give you your second view quiz answer, which is the letter C. C as in cat. C as in cat is our second view quiz answer. Okay, so we are so S3 again, very, very informal. All right. And so here, to create a new class, you can use this function structure. Okay. And here you build a new class out of base objects. So here my base object is a list. This is a list containing the string apple. That's my base object. And here I'm going to say, hey, you know what? We've got a new class. The new class is called fruit. And that's it. Now we've created a new class in R called fruit. All right. You can also just take a existing base class object. So here I've got a list. Y is a list containing the string banana. And then I just say, hey, class of Y is now fruit. And that's it. Now we've created a brand new class. Okay. There's no formal definition. It's just like R says, oh, okay, the class of this thing is fruit. And then later on I say, hey, that object X that we created earlier, what's a class? And R says, yeah, you know what? The class of that thing, it's fruit. And that's it. Okay. And then you say, hey, is X a fruit class object? You say inherits X from fruit. And R says, yep, it's a fruit class object. Okay, very informal. It's just, oh, I guess we're doing this now, right? It's like showing up to the store and you go, oh, whoa, that's new. I guess we're doing that. Okay, and that's our system. It just says, oh, fruits? Yeah, all right, we're doing fruits today. Okay. When you give it a class, okay, you can actually, the class can be a vector. Okay. And so when in the tidyverse, Tibbles, when you ask what's the class on this thing, diamonds is a Tibble, it's actually a vector. Okay. And it kind of shows the order of inheritance here. So you got Tibble underscore df, which inherit from Tibble, which inherit from data.frame. Because Tibbles you can think of as like a special kind of data frame. And I'm actually not sure the difference between Tibble underscore df and Tibble, but they basically inherit from data frames. And so they behave very similar to data frames. There's just a few things that it does a little bit special and a little bit different. Okay. If we look at the column cut, $cut, it's a factor, but it's an ordered factor. And so the class vector is length 2. First, it's an ordered, which means if we have methods specific to ordered things, use that. And if not, just use whatever methods exist for factors. Okay, and that's what we look for, right? You can check to see if something inherits, it belongs to a certain class. So, is diamonds $cut a factor? And that returns true. Now, you might have wondered, like, why do we need inherits this, right? Can't I just do class, is that class object equal to class name? Can't I just do class diamonds $factor? I mean, class diamonds $cut, is that equal to a factor? Okay. The problem with that is, remember, this class thing is a vector, And so when you say, is it equal to factor, we actually get a vector of length 2, a false and true, right? And if you just want to know, hey, is it a type of factor? Yes. Use inherits there. So inherits is the recommended method versus just is the class equal to something. So rather than saying like, is the class equal to fruit, you should do inherits from fruit. Okay. Now again, S3 doesn't require constructor functions, okay? S3, when we wanted to create a new class of fruit, I could just do it in this very informal way and it works, okay? But we recommend having a constructor function. A constructor function is a function that you use to create objects of that class. So we have, for example, we have the function factor, and we use factor to create factor class objects, okay? We have the function data.frame, and we use data.frame, the function, to create objects of class data.frame, okay? And so these are constructor functions. We use those functions to create objects of that class, okay? And so anyway, this is what we have regarding constructor functions. So let's say we want to create a constructor function for fruit, okay? Fruit is going to be a constructor function, and basically it's going to return, the last line of the fruit function is going to return an object of class fruit, okay? And it just has one check, and it just says, hey, let's just make sure the thing coming in is a character vector, and if it isn't, throw an error, okay? And if it is, put it in the list and call it a fruit. All right, so here I say, all right, let's take pineapple, turn it into a fruit. So Z is now a fruit class object. And I say, hey, what is pineapple? Or what is Z? Z says, oh yeah, it's a list containing pineapple. And look at that, the class attribute is fruit, okay? And it's as simple as that, okay? So we have, you've probably used the function LM to create linear models in like your 101A linear regression class, right? That's actually a constructor, okay? It's a constructor. You give it something like a formula, it does a bunch of calculations, and then it returns everything in a big list that is of class LM, okay? So if I say, hey, what is the class of this linear model that I just created? The class is LM. And then when you print LM, there's a special function called print.lm, and print.lm says, oh, I'm going to look through that big list, and I'm going to pull out certain pieces of information and print it out. And so it prints out things like the intercept and the slope and the call and the formula. It prints out, this is not how a normal list prints, this is how LM objects print, okay? Now, S3 being a very informal system, it relies on trust of the user, okay? And so you can break things. And you can say, oh, you know what, that object, LM empty cars that we just created, you know what, it's not LM. I'm going to change the class of it to data frame, okay? And R goes, oh, okay, I guess it's a data frame. And then you say, print it out now, all right? And R goes, well, that's funny. I'm supposed to print this like a data frame. And so R tries to print it like a data frame. There's 12 things in the thing, and it tries to, data frames, it's expecting columns. So it tries to make these the columns, and it says, I've got 0 rows now. This is weird, but okay, this is what you asked. And it does that, right? And you go, oh, yeah, that looks funny. And it feels like, do we lose the information? No, the information's there. I can still say like, hey, what are the coefficients? And it still gives you the intercept and the slope, but now R thinks this is a data frame class object. This is like going to the grocery store, okay? And then you buy an apple and an orange, and it's like you peel off the sticker off of the apple and you stick it on the orange, okay? And then you go to the cash register and you scan it, and it says, oh, orange, 69 cents or whatever. That's stealing, by the way. But you know, the system relies on trust that you're not going to peel the label off of one thing and stick it on another thing, all right? But if you wanted to do that, R lets you do that, and it doesn't throw an error in it, and it just gives you funny behavior. It says, huh, this is, you know, a funny looking apple, but there you go, okay? And so yeah, you know, while you can change the class of the object, don't do it. R is not going to protect you from yourself, but that's that, okay? Let me show you a few examples of how we can like create our S3 generic and get things to work here, okay? So when we have a generic function, that's basically saying I've got a bunch of different versions of this function, right? I've got t.dataframe. I've got t.default, which is used for matrices. I've got t.ts for time series. We have different versions of these things, and when you call t, R says, oh, I'm going to look for the proper version. So if you want to create your own generic function, you can do that, okay? And to do that, you use the function use method. So I'm going to say, hey, I want to create a new generic function called quotation, okay? And I'm going to have different versions of quotation. I'm going to have a quotation dot this, and a quotation dot that, and a quotation dot something else. And they're all going to start with quotation, and we call use method. And so R now is going to rely on the naming convention, and this says, okay, this is generic function here, okay? So I'm going to create quotation.fruit. This is now going to work for fruit class objects, and quotation.fruit just returns a quote. Fruits are an important part of a balanced diet, okay? And so here I say, all right, let's make a new object, x. X is of class fruit. I can just double check. What's the class of x? It's fruit. And so when I call quotation on x, what happens is R says, okay, you are calling quotation. The definition of quotation is this, use method quotation. Oh, it's a generic function. That's what R is saying. And it says, okay, it's a quotation. What is the class? The class is fruit. I'm going to look for something called quotation.fruit. It finds quotation.fruit, and it returns this quote, okay? Fruit's an important part of balanced diet, okay? So that's how it works. This is the generic function. We call the generic function. R says, oh, I got to look for the specific version applied to fruit, and there it is, okay? You can take existing generic functions and give class-specific methods, right? So the function mean, we saw, is already a generic function. There's mean.default, there's mean.date, mean.time series, or I don't know, not time series, but mean.closure and all of these other things that I didn't quite understand, but it's a generic function, right? So I could say, you know what, I want to have a function of mean that applies to fruit class objects, okay? And this is it, mean.fruit, okay? And you go, well, what's the mean of fruit? I don't know, but we're going to have the function just return the number 5, okay? It's a stupid function, but that's what we have, all right? And so this we call mean.fruit, all right? It's going to return 5. And so x is banana of fruit class, and so we say, hey R, what is the mean of x? And R goes, huh, it's a fruit class. Do we have mean.fruit? Oh, look, I did find mean.fruit. Okay, and so I return the value 5, okay? And it does that, all right? So how does it work? R just, all it does is it says, all right, here's the generic name, okay? Mean, and what's the class? The class is fruit. I'm gonna look for generic.fruit. So it relies entirely on this naming convention. If you call it anything other than mean.fruit, R won't know what to do, okay? And then it has always a fallback of .default, okay? So if it can't find mean.fruit, it's going to fall back to mean.default, okay? All right, so here's just a few more methods. And so I'm going to create a method for quotation.fruit, quotation.apple, and quotation.default, okay? And so we can accept, for fruits, we can accept dot apple apple class objects, and then if we don't have fruit or apple class objects, we'll get back the default. Okay, I'm gonna give you your last view quiz answer. Not to the video people. Sorry, video people, you won't get the answer. All right. So we have these 3 methods: quotation.fruit, quotation.apple, quotation.default. Okay, so let's just execute a few things. So here I'm going to create an object, and object A, and it has class apple and fruit. And so when I call quotation A, R looks for first quotation.apple. It finds quotation.apple, and it says an apple a day keeps the doctor away. Okay, all right. Here's another one. All right. Object B, its classes are banana, but also inherits from fruit. Okay. So first, R is going to search for quotation.banana. We don't have quotation.banana defined. Okay. So it looks at the next one. It says quotation.fruit, and it finds quotation.fruit. And so it returns fruits are an important part of a balanced diet. Okay. And then here's the last one. Its class is donut. Okay. So it searches for quotation.donut. There's no quotation.donut. So it falls back to quotation.default, and it gives me back the default quotation. Okay. So again, the S3 system relies on us following the naming conventions. Now, if you want, you can force, right? So quotation follows the generic, the generic function naming convention. So it's going to search for quotation.banana, doesn't find it, and then it uses quotation.fruit. Okay, so it gives us that. Now, if you want to, you can say, you can override it and say, I want you to use the apple function, quotation.apple function, on object B. Okay, and it does that. Okay, and this is just kind of like going to the cash register, and it has the correct label. It's an apple, but then you tell the cash register, oh, can you just ring this up as an orange? And the cashier goes, sure, and goes along with it. Okay, again, not great. All right, now if you don't have, like if I delete quotation.default, and then you call something like this, R is going to complain. It's going to say, hey, I couldn't figure out, there's no quotation.donut, and I don't have a .default either, so I couldn't figure this out. Okay, inheritance works the same kind of way. It's got, you know, the vectors, and it's going to search for the thing. And so there's this library called Sloop that just says this is what it searched for, and this is what it found. So we have a ordered factor, and it searches for print.ordered. It couldn't find print.ordered, and it finds print.factor, and that's the one that gets executed. Okay, it didn't have to use print.default. Okay, and I have a self quiz that you can do on your own time. It's a whole bunch of slides, and I think I have a recorded video from a couple years ago where I go over the answers of this thing. But I say, like, all right, here's a function, here's a generic function. I've got specific methods. What is it gonna do? And so here the generic function is f. I got f.j, f.k. K is the value 1. And what happens if I call f on k? Okay, well, k is just an integer. It's not a class. So it's going to use the default, and it's going to say I couldn't figure it out, right? I couldn't find f.default. Okay. So anyway, I've got the self quiz that I recommend you guys check out. Okay, we will end here for today. I know you guys have questions about the midterm. I'll talk about that on Wednesday. All right, so just wait till Wednesday for your midterm questions. Okay, see you then.